Okay, let's look at the problems on slide 17. It asks us to use the periodic table to fill in the atomic number, number of protons, and number of electrons for each of the elements that are listed. We'll start with Na. Na is the symbol for sodium. And then we have zinc. Zn is the formula for zinc, or the symbol for zinc. And then we have S for sulfur. Here we want the atomic number, or otherwise also known as Z. We want the number of protons, and we want the number of electrons for each of these. Okay, so let's talk about each in turn. The atomic number, as was mentioned in lecture, is the number that is found right above each element in the periodic table, each symbol. And if you look up sodium, that number above sodium is 11. So sodium's atomic number is 11. Now the atomic number also tells us, it gives us the number of protons. You can know the number of protons for any element in the periodic table just by looking at the number that is right above it. That number tells you the atomic number, which is equivalent to the number of protons. Therefore, because sodium's atomic number is 11, we know that sodium has 11 protons. And once again, the number of protons is unique to each element. If I change the number of protons, I change the element. Therefore, for the same type of element, all of its atoms will contain the same number of protons, and that is 11 in this case because I have sodium. If I'm looking at an atom, a neutral atom, there is no charge associated with it. So if I want to determine the number of electrons when I'm looking at sodium, it's a neutral atom, which means that the total positive charge will have to equal the total negative charge. I know what my total positive charge is, it's 11. That means my total negative charge will have to be 11 as well. And because each electron carries one charge, that means that I will also have 11 electrons. This is for a neutral atom. Okay, now let's look at zinc. Zinc, if you look at it in the periodic table, will have an atomic number of 30, which means that also tells me that it has 30 protons, because these two are the same. Once again, if you want to know the number of protons of an element, you just look at it and figure out what is its place in the periodic table. If it's number 30, as zinc is, then that means it's got 30 protons. If you were given the number of protons, let's say you were given this particular element has 30 protons. What is it? What is the identity of this element? Well, the number of protons tell you what place it is, the atomic number, the place it is in the periodic table. So you would look up number 30 in the periodic table and you would see that it was zinc. Okay, because it's a neutral atom, it doesn't have any charge, that tells me that the number of protons has to equal the number of electrons, which means that it has to have 30 electrons as well. Now let's look at sulfur. Sulfur's excuse me. The atomic number of sulfur is 16. The atomic number, once again, tells us the number of protons. And because it's a neutral atom, the number of protons has to equal the number of electrons. So I have 16 electrons as well. Now this is for neutral atoms. What if I had ions? So let's say I had sodium ion, sodium plus. Okay, well, for this to be sodium, whether it's an ion or if it's a neutral atom, it has to have the same number of protons, because if I change the number of protons, it's not going to be sodium anymore. So whether it's a neutral atom or the ion of that element, it doesn't matter. The number of protons does not change. So sodium also has 11 protons. However, it changes in the number of electrons. This plus here tells me, well, it's a positive ion, so it tells me that I have a surplus, or I have more positive charge than I do negative charge. And that means, I don't have it written out here, but if it's implied that it's a 1 plus 1, and the number there tells me how many more protons I would have versus electrons. The 1, as I said, the 1 charge tells me that I have 1 more proton as I do electrons. Therefore, sodium will only have 10 electrons. Sodium ion. The sodium metal has 11, but sodium ion only has 10. It has lost 1 electron, and now it has 1 more positive charge, 1 more proton than it does electron. Let's look at zinc. Zinc forms the 2+ ion. Okay, the plus tells me that I have more protons than I do electrons, and the number 2 tells me how many more. If I start, once again, don't confuse electrons with protons. Protons do not change. Zinc, it's zinc atom and zinc ion. Both of these will have the same number of protons, will have 30 protons because they're both zinc. If I change the number of protons, it's not zinc anymore. So this has 30 protons. However, it has 2 more protons now as an ion than it does electrons. That 2 tells me that I have a surplus of positive charge by 2, which means that I will have only 28 electrons in the ion of zinc, zinc 2+. Now let's look at sulfur ion. Sulfur ion is a 2-. Sulfur forms a 2- ion. Okay, the negative charge now is slightly different. The negative charge tells me that I have more electrons than I do protons. The protons have not changed. They're still 16 because these are both sulfurs, even though this is an ion. What changes from a neutral atom to an ion is that they lose or they gain electrons. Well, in the case of sulfur, I have 16 protons, but I have more electrons than I do protons to give me a negative charge. That negative tells me I have more electrons. And the 2 tells me how many more electrons I have than protons. Because I have 2 more electrons, that means that I will have 18 electrons. Or sulfur 2-, S2-, has 18 electrons instead of just 16. Like the neutral sulfur does. Okay, I will erase this and then we will continue on with the problems in the next slide.